Hi, this set of videos will talk about interest rates and inflation. I will also discuss the economic factors that changes interest rate and inflation. I will use 3 videos to finish this lecture. In the first video, I will explain effective annual rate and annual percentage rate. We may have some problems related with cash flows occurred monthly, quarterly, and we may have some problems related with cash flows occurred every 2 years or every 4 years. How can we solve these categories of problems? We need to use effective annual rates to switch from these cash flows with different time periods into general problems with annual frequency. I also want to compare effective annual rate and annual percentage rate. Effective annual rate is based on compounding calculation, but annual percentage rate will be based on simple interest rate calculation. In the second video, I will explain inflation rate and real interest rate. In a synchronized course of this part, I will go over some practice problems with real interest rate. Then in the third video, I will talk about factors that affect interest rate, and we will discuss some interesting facts about yield curve. Okay, in previous slides or previous videos, we generally discuss problems related with annual frequency. So the cash flows occur year by year. What if the cash flows occur by monthly or by quarter? Or we have cash flows occurred every 3 years or 4 years. We need to figure out the way to solve these kind of problems. Effective annual rate will convert the annual discount rate to a longer period or a shorter period. Here is the equation to do this conversion calculation. If we have the periods shorter than 1 year, for example, monthly calculation or quarterly calculation, then we can use the first equation to calculate the effective annual rate. If we have the monthly cash flow, then we use this monthly periodic rate, and we use it 1 plus monthly interest rate to the power of 12 months minus 1 as the effective annual rate. If it is a quarterly cash flow problem, then we use 1 plus quarterly interest rate to the power of 4 quarters minus 1. Then we will get the effective annual rate for this quarterly problem. We can do a similar calculation for the opposite direction. If we know the interest paid every 3 years or every 4 years, we can use this second equation to back out the effective annual rate required for this long period interest rate. Now I want to compare annual percentage rate and effective annual rate. If we have read the advertisement from some banks, for example, the credit loans or the credit cards, they may say, well, I will provide the credit card with 6% APR with monthly compounding. Can we say the effective annual rate is 6%? Well, we cannot say for most cases. Here, it is a monthly compounding description. So the bank will use 6% over 12, that is 0.5% as the monthly interest rate, and then do this 12 months compounding calculation. So the interest rate for this compounding calculation by the banks or some insurance company, it will be this annual percentage rate over the periods. Let's do a calculation to see the difference between annual percentage rate and effective annual rate. Here we have this annual percentage rate at 6%. It is compounded monthly. Then the monthly interest rate will be 0.5%. We do this compounding calculation for 12 months. So then we found for a year, the interest rate is 6.17%. So the effective annual rate at 6.17% is higher than 6%. This equation tells us how we can convert from annual percentage rate to the effective annual rate. First, we use the annual percentage rate over the period number. Then we do this compounding for n periods. In this way, we back out the effective annual rate. Generally, this annual percentage rate will be lower than this effective annual rate. This slide provides a sharp illustration of this how annual percentage rate is lower than the effective annual rate. If the bank uses the annual percentage rate to do annual compounding calculation, then it's okay because the annual percentage rate will be equivalent to the effective annual rate. But if the bank uses this annual percentage rate to do twice compounding during a year, then we will have this biannual interest rate at 3%, and we do this compounding twice. So then the annual interest rate will be 6.09%. It is higher than 6%. If we do this quarterly compounding, the interest rate for compounding calculation will be 6% over 4. It is 1.5%. Then you do this compounding for 4 times during a year. So then after 1 year, the interest you paid will be 6.136%. If we do this monthly calculation, we find for the monthly compounding rate, it will be 0.5%. You compound it twice for 12 times during a year, so then the effective annual rate will be 6.168%. It is higher than 6%. If we have more and more periods during a year for this compounding calculation, the effective annual rate will be higher than this annual percentage rate. Now, after watching this video, we should be careful with this description of credit card or consumer loan. After we find the number for the annual percentage rate, we want to rate the details of compounding, whether it is quarterly compounded or monthly compounded. Thanks.